Welcome to Unit 2 of Business Analysis. I'm your instructor, Diana, and I want to go over a few things with you in the Unit 2 lecture that will help you get through the homework assignment. So let's look at Chapter 2. Your required reading this week is the entire Chapter 2, but I'm just going to go over some of the highlights for you. Let's look at Chapter 2, where we're talking about probability. Okay, so we all understand by this point probability. Life is not certain. We're not exactly sure what the future will bring. So probability is just a numerical statement that'll tell us how likely a specific event is to occur. And we use probability all the time. So the probability of any particular event, and we're going to use probability as the capital P in our reading here. The probability of any event occurring is going to be greater than or equal to 0. So there could be a 0 probability that something's going to occur, or it could be something up to 1. Now, if the probability is 1, then there's a 100% chance that event is going to happen. So there's no risk there. If the probability of that event is 0, there is no possibility of it occurring. So again, there's no risk there. The risk comes greater than 0 and less than 1. There's some probability of the event occurring, but there's a risk because there's also some probability of it not occurring. So we have an example in our textbook that talks about the demand for white latex paint at a paint company. And demand has always, the supply of this paint has always been either 0 cans, 1, 2, 3, or 4 gallons per day. So what we've done is we've looked at 200 different days, and we see that on 40 of those days there was no gallons of paint demanded. On 80 of those days there was only 1 gallon requested, and on 50 days there were 2, and 20 days there were 3, 10 days there were 4 gallons of paint demanded. And so we could take those 200 days and develop a probability of the number of cans that will be demanded on any given day. So what we've done is we take the number of days that a certain quantity was demanded. For example, there was 0 quantity demanded on 40 different days out of 200 total days. So 40 days divided by 200 was a 20% probability that 0 gallons of paint will be demanded. And there were 80 days in which only 1 gallon was demanded. So if we take that 80 by the 200, we will find that there's a 40% chance that 1 gallon of paint will be demanded on any given day. So we've continued down for each quantity that's demanded and determined what the probability is of that number of gallons being demanded. And we see that all of the probabilities total 1. So there's a 100% chance that one of those quantities between 0 and 4 will be demanded. So what you will do with this probability formula of taking the number of occurrences of a particular outcome divided by the total outcomes, and that gives you the probability of that particular outcome occurring on any given day. And you're going to see this on page 23. There's your formula. The number of occurrences of an event divided by the total number of trials or outcomes gives you the probability of any specific event. And this example is very similar to our number 1 problem on the homework assignment. So when you start on the homework, you may want to refer to this particular example and page 23 in your text in order to properly complete that. In the homework assignment, you will have a total of 300 students, and you'll have information as to how many students made each grade, A through F, and you'll be able to calculate the probability of a student receiving any one of those particular grades using the information you have here, the number of occurrences of the event divided by the number of trials or outcomes. Then you should be able to add up all of the probabilities, and they should arrive at 100% or 1. So when we're talking about types of probabilities, there's a lot of information in Chapter 2, so make sure you're reading through that carefully. But some of the things I want to highlight is when we talk about objective probability, we have the relative frequency method, and that's usually based on historical data. So we've got, like in the last example, a number of occurrences of an event, and then we're going to divide that by the total number of trials or outcomes. So we use relative frequency on that previous example. Now we also have a classical or logical method that we can use to determine probabilities that don't have trials. For example, when we're flipping a coin, we don't need to create a number of trials to get the probability of getting a head or a tail. It's 1 out of 2. So when we don't need to do trials, we can use that classical or logical method of determining the objective probability. Now, subjective probability is different from objective in that subjective probability is just like it sounds. It's based on the experience and judgment. Oops, back up. Sorry about that. I started moving my mouse too much. Subjective probability is based on the experience and judgment of the person that's making the estimate. So we're talking about opinion polls, judgments of experts, and the Delphi method, which you can read about. So subjective is just as it sounds. It's based on experience and judgment. Now when we talk about mutually exclusive events, we're talking about events that can only occur if another event has not occurred, or if an event can only occur, only one of potential events can occur in any one trial. For example, tossing a coin is going to result in either a head or a tail. If you get a head, then you can't get a tail in the same event. When you're rolling a dice, you're only going to get one of the possible 6 outcomes. If it lands on a 3, it doesn't land on any other number. So those events are mutually exclusive. We also are going to read about mutual or collectively exhaustive outcomes, and they are collectively exhaustive if the list of possible outcomes includes every outcome. For example, on the roll of the die, there are 6 possible outcomes, and that includes every possible outcome. I don't think a die can land just on a corner. So of all the possible outcomes, all 6 of them are listed. So this list of events is considered to be collectively exhaustive. Now, we also need to understand events that are statistically independent. Events can be dependent or independent, and when we have an independent event, this means that one event occurring has no effect on the possibility of it occurring again in a separate event. So if I flip my coin and I get a heads this time, that event has no bearing on whether or not I may get a heads next time I flip it. It's an independent event. So some events which are independent versus dependent can be understood by using these examples. So your education and income level in most cases are dependent on each other. from what we're told, your income increases with education. So your income level is in some part dependent on your education. Whether or not you pull a jack of hearts from a full deck of cards is completely independent of whether you would draw a jack of clubs from a full deck of cards. Pulling one and then repeating the occurrence does not have any effect on the possibility of what event will occur the next time. Let's see, a baseball team winning their National League is a dependent event of them winning the World Series, because you can only go to the World Series if you've won the national event. So those events are dependent on each other. The fact that it is raining in Israel is completely independent of whether or not it's snowing in South America. These are independent events. So we get the idea of dependent variables versus independent variables. We also have three types of probabilities we want to point out. Marginal probability is just the probability that a single event is going to happen or occur. But the joint probability is a probability of multiple events occurring. And it's the product of their marginal probabilities for independent events. So if we take each of their marginal probabilities, the two separate events, multiply them times each other, then we will get the joint probability of both of those events occurring. Now, conditional probability is the probability of an event based on the fact that a different event has already occurred. Now, this example also is something that we're going to be able to use in our homework. So watch closely on the next couple of slides. When we look at probability distribution, we're saying that all events are going to be mutually exclusive and collectively exhaustive. So only one of the outcomes can happen per trial. And the total of the probabilities includes every possible event. So each probability is going to have a value between 0 and 1, and the total probabilities will equal 1. So what we've got here is an example where we have 100 people responding, and we have a count of how many people responded to each answer. Some 10 people answered 5, 20 answered 4, 30 answered 3, etc. So what we've got here is the probability, sort of like the earlier example. First, we're going to get the probability. So if we take 10, the number of responses of 5 that we got, and divide that by the total of respondents, so that is 10%. So there's a 10% probability that the response will be 5. Likewise, we have a 20% probability that the response will be 4. A 30% probability that the response will be 3. Okay, so we've got the idea here. This is just like the previous example. So we have here just a chart of the probabilities. We've got the answers or responses down across the bottom. So the responses were 1, 2, 3, 4, or 5, and the probabilities going up the left. So we see there was a 30% probability of a 2 or a 3, a 20% probability of a 4, and a 10% probability of a 1 or a 5. Now, the central tendency of the distribution is the mean. That's the average. That's the expected value. And the amount of variability is what we call the variance. So you've got this formula in your text for the central tendency distribution. But I'm going to move a little bit past that and let you read that part, because we want to focus on how to complete this in Excel, which is how you would realistically do it. You would use Excel rather than by hand with the formulas. So let's keep going. But here's the formula spelled out for you. The easy version of this formula is that we're going to take the outcome. So the first outcome was 5. There was a 10% probability of that outcome. So we take 5 times 0.1, or 10%. There was a 20% probability of a 4 outcome. So we take 4 times 20%, etc. So we take each possible outcome times the probability that that outcome will occur, and we just simply add all those together. And that will give you the expected value. And problem number 2 of your homework is just like this. You're going to be given information about the number of loaves of bread sold and the probability of each occurring. So you won't have to calculate the probabilities on that problem. But what you will do is take each outcome, which is the number of loaves, times the probability that it will occur, and for each outcome, you will do that, the number of loaves times the probability. Then you will add all those up, and that will give you the expected value. So remember this part when you get to problem number 2 in your homework. You're going to calculate the expected value in a probability distribution. So here's what that will basically look like in Excel. So P is the probability and X is the outcome. So we see X is 5 on the line 2. The probability of that occurring is 10%, or 0.1. So in column C, we're multiplying the outcome times the probability. And in column D, what they're going to do is, first of all, sum all of those. Look down on cell D7, we're summing those answers. And in D8, we're getting the square root of that. That's going to give us the variance, but we don't need that part for the homework. We just need to get the expected value, which goes down to line 7. Okay, so when we use Excel, and we're only going over to column C, because that's what we need for the homework. But you'll read about the variances and the standard deviation, because that's additional material that you will still need to know, and that may be on your test. But the homework problem, I just want to show you exactly the steps you're going to go through. You're going to go through the steps that are in columns A, B, and C. A is given information in the homework problem. The probability information is given in the homework problem. You're going to calculate column C, and then you're going to calculate cell C7, which is the expected value. So you'll apply this slide to the number 2 homework problem. Next, I want to talk to you about binomial distribution. A lot of business experiments, rather, use this process, and it's very popular for certain types of problems. And in this, each trial has 2 possible outcomes: pass or fail, yes or no, in or out. There's 2 possible outcomes. The probability of each outcome stays the same from one trial to the next. So that means that all the trials are independent. And the number of trials is a positive number. So let's look at this binomial distribution. So if we have the number of trials and a probability, the value of R we're going to use as the number of successes, and probability, of course, is P. We're going to look at what we're showing in this chart here. Here we go. Here's what I want. Okay, here's how you're going to solve this problem in Excel. So if the question is asking, for example, from problem 3 of your homework, how many of a batch of something will be defective, or how many will be either one of 2 things, in or out, off or on, defective or not, you get the idea. So N, again, is the number of trials. Probability is the probability of a success. So a success is whatever you're looking for. If my success is that a heads, then that would be what I'm measuring. In the homework assignment, a success is going to be a defective item. That trial was a success, or identified a defective item. So to calculate the probability of a specific item being defective or not, you're going to use binomial distribution function in Excel. So in Excel, you will find this function. If you've never used it before, you will probably have to go to all functions to locate it. So it's in the FX bar above your spreadsheet. You'll see FX. You click that and select the function that you want, binom distribution. So all the Excel instructions, are in your textbook. If you're not familiar with Excel or how to find that function, your textbook will help you with it. Look for this on page 41. And so what you're going to do is you get the binomial distribution function, and that function box is going to ask you for pieces of information. The first thing that function asks you for is the number of successes that you're trying to measure. And so in this case, you're looking for 4 in this example here. And then the next thing it's going to ask for is the number of trials. The next thing it's asking for is the probability of occurrence. And we're going to select, in this case, true if we want the cumulative probability. Now, if you do not want the cumulative probability, then you'll select false. So, for example, in the homework, we're trying to get the probability that a certain number of cases will be defective. So if we're trying to get the number of cases that will be defective, in the first box in Excel, the first argument that it's asking for is going to be 0, because we want to know how many is defective, and we want the probability that 0 is defective. Again, I'm talking about the homework assignment now. And then we also, in the trials, we want the number of trials that there has been, that we're given, and the probability of all cases being defective, of a case being defective rather. I feel more comfortable if I pull this out for you, so let me do that. Okay, so here we are. Here's the assignment, problem 3. So you're going to go to this function box and select binomial distribution, binom dist. And let me move over so you can see the problem, or move up rather, so you can see the problem at the same time. Oh, it doesn't like that. Okay, now we're going to pull up binom dist under recently used. Bear with me, I'm getting there. Just want to get you started on this correctly. Okay, here we go. So we've got binomial distribution. So the first thing we want in this example is the probability that 0 cases will be defective. This is what we're looking for. So we're going to use the binomial distribution function in Excel to locate that. So the number of successes that we want is 0. We want the probability that none of them will be defective. So you would put a 0 in here for the number of successes. The number of trials is the number of trials that we are given. Now it says in the problem that the firm is going to sample 10 cases, so that would be our number of trials. The probability is the probability that we're given, and it says in the problem that normally 5% of all cases are defective. So our probability here is 5%. And I'm just typing these numbers in, but I am going to suggest that you just if you want, you can put the information into a separate column so that you can just click the cell reference. But certainly you can just type them in just like I'm doing here. Now, there's really no cumulative for this because we want the probability that the exactly 0 cases will be defective. So in this case, we would enter false. Now, look at the part 3 of that. Part 3 says the probability that up to 2 cases will be defective. So here, we actually do want a cumulative probability. So that's a case where we would enter true because we were getting up to 2 cases. So we want the cumulative probability of 0, 1, or 2 cases being defective. Okay, so let's go back to our example. So in this example, they've done exactly that, just using the sample data from the problem in the book. But you will apply this like I showed you to the homework. And you put in the number of trials, the probability of success, and the specific number of successes. So that is the binomial distribution problem. Now, the normal distribution is also very popular. And we do, like I said in the book, have the formula listed of how you would calculate that by hand. But again, we're going to focus on using the tools to do this work for us, these calculations. So we're going to look at how to do that in Excel. But what we need to know about normal distribution is that the midpoint is the average. And so when we shift the average, that doesn't change the shape of the distribution. The distribution shape, the bell curve, is still going to be the same. And so the values on our x-axis are going to be a certain number of standard deviations away from the average. And you're doing your reading in Chapter 2 about standard deviations. And so you'll learn that as the standard deviation becomes larger, the curve flattens. As the standard deviation becomes smaller, the curve gets steeper. So here's an example we're going to work through from the text. This company has a construction company, and they're supposed to complete a contract in 125 days or incur a penalty. So what they want to know is what is the probability of completing this project in 125 days. This is the type of problem you could solve using the normal distribution. So your slides from Chapter 2 in the course content area walk through this example for you and how to use a normal distribution. I am going to go ahead and show you the Excel, and then I'm going to show you the the homework problem that's just like this. So this example is here for you to review in the slides, but I want you to make sure that you apply these concepts to the homework problem. So I'm going to show you that one. Okay, and I'm just grabbing that for you. I've got so many different files open. Okay, here you go. So here is your example assignment. So, your homework assignment rather. So we've got some information here, and on problem 4, we're going to use normal distribution. So let's find that in Excel. Normal distribution. It's norm.dist. Here we go. So we're going to use normal distribution. And here's what it's asking for. X. That is the number for which you want to find the distribution. So this is the 4,000 in this first problem. We want the probability that sales will be less than 4,000. So that's our distribution. The mean is the average. And so the problem says that the average sale of oranges is 4,700. And so we would enter the 4,700 as the average. The standard deviation is 500. That's also given in the problem. And we want the probability that sales will be less than 4,000. So since we want less than 4,000, we're going to put true here because we want all the probabilities cumulative for anything that's less than 4,000. If you wanted only the probability that it would be exactly 4,000, you would enter false in that last box. And that's how you're going to use the normal distribution. So this information, again, is you've got an example in your textbook in the PowerPoint slides that you can review. You can also review that in it's going to be in the actual homework. It's an exact problem that using normal distribution. So we are running short on time. I hate to make these videos too very long, but I do want to cover all of the homework problems in them. So the last thing I'm going to look at here is the exponential distribution because there's a homework assignment related to it. So the exponential distribution is also called the negative exponential distribution. And this is often used in queuing models to determine how much time it takes to do something, like service a customer. So the example in your textbook and in the slides talks about a muffler shop that installs mufflers on automobiles and small trucks, and a mechanic can supposedly install 3 an hour. And so the service time is exponentially distributed. So what we want to find out in this example is what's the probability that the time to install is going to be less than half an hour. So normally they can do 3 an hour, so 20 minutes per install. So we want to know what is the probability that it would be a half hour or less. And so in order to complete this, we would use the exponential distribution function in Excel. You see that here, expon dash dist. And the first thing you're going to enter is the average. The average is 3 per hour. Oh, I'm sorry, the first thing you're going to enter is the amount of time that you're getting the distribution on. The amount of time, it says here, is 0.5 because it's referring to half of an hour. Because our hour is our standard amount of time in this example. Then the next thing we're going to enter is the normal average, which is B2. Normally it's 3. So we're wanting to know the distribution and probability of it being in half an hour versus 20 minutes. And we are going to say true because we're getting a cumulative response for anything less than half an hour. So 1 minus your answer there will tell you the probability of it being more than an hour or more than half an hour. So the exponent distribution function will tell you the probability of an install taking less than half an hour. And then if you subtract that answer from 1, that'll tell you the probability of it taking more than half an hour. So let's look at your homework problem related to this. And this is problem 5. Problem 5 says we're in a call center and the normal calls take about 4 minutes. So that's a quarter of a call, 0.25 of a call per minute. And the time follows exponential distribution. So we're wanting to find the probability in the first one that a call will take less than 2 minutes. Okay, sorry about that. So we're going to take the expon dist function to solve this. So you'll go to Excel. If you've never used it before, like I said, you may have to pick it from the list. Once you pick it from the list, it'll be in your frequently used. Okay, so the first thing is the time that we're trying to test. So the time that we're trying to test is the 2 minutes. The next thing you're going to enter is what it averages. It averages 0.25 calls per minute. And for the cumulative, we are going to enter true. So we had 2 minutes, 0.25, and true for the first part of question number 5, and that's going to give you the answer there. So then you just complete the other two. And remember, when we get to part 3 of problem 5, remember what I just told you about here. 1 minus that answer will give you the probability of it being greater than the time that we measured in that formula. So that's going to help you on a part of that also. So we have reviewed each part of your homework assignment. So I know these slides for chapter 2 are very long. There's like 110 total slides, and you could get lost in that easily. So once you read the chapter, view my video here, then you will have gone over all the points you definitely need for the homework, which was the calculating the probability. That's on page 23, and that's what you'll use to calculate the first homework problem. Then you calculated the expected value. That's on page 35 of your text, and that's problem 2 of your homework assignment. I also showed you how to use the binomial distribution function. That is on page 41 of your text, and that relates to problem 3 of your homework. Then I showed you the normal distribution function. That's on page 47 of your text, and that relates to problem 4 of your homework. Then problem 5 of your homework is the exponential distribution function. That's on page 52 of your text, and like I said, problem 5 of your homework. So again, I know there's a lot of information in chapter 2, but at least this will give you some areas and page numbers to focus on, so that you can get your work completed in a timely manner. And the discussion this week talks about just probability in general and how you might apply probability concepts to your everyday life. So you make sure you're participating in the discussion. And I am available for office hours, 8:30 to 10, Monday and Tuesday evenings, and by appointment or by email at any time. You can always email me and I'll respond within 24 hours. So good luck with that. If you have any questions, make sure to send me an email, and we will talk again soon.